The sun, our life-giving star, is not always as benevolent as it seems. In fact, it has the power to unleash massive storms that could wreak havoc on Earth. But what exactly are solar storms, and how do they affect us? Join us as we delve into the fascinating world of solar weather and explore the potential impact of these cosmic phenomena on our planet. Welcome back, everyone, to Theoretical Theatre. Today, we're diving deep into the topic of solar storms and their potential impact on Earth. But before we get into the details, let's take a moment to understand what solar storms are and how they occur. So, why should we be concerned about solar storms? Well, the answer lies in their potential to disrupt our technological infrastructure and even pose risks to human health. But just how severe can these disruptions be? Let's find out. It all begins with the solar cycles. The solar cycle, an 11-year pattern of fluctuating solar activity, sets the stage for these cosmic dramas. It begins with a quiet interlude, punctuated only by a scattering of sunspots, those telltale signs of solar unrest. As the cycle progresses, the sunspots multiply, reaching a crescendo 5 or 6 years later when the solar activity peaks, sometimes boasting as many as 100 to 200 sunspots adorning the sun's surface. Then, like a grand finale, the solar activity gradually subsides over the remaining 5 years, only to herald the dawn of a new cycle. Currently, we find ourselves amidst the 25th cycle since our meticulous tracking of the sun's behavior commenced in 1755. Unfortunately, astronomers foresee a zenith in sunspot activity around 2024, heightening the likelihood of solar storms. Sunspots, characterized by their cooler and darker appearance, emerge on the sun's surface under the influence of intense magnetic fields. While they themselves do not generate solar flares, their magnetic potency often coincides with heightened flare activity. Consequently, solar flares tend to manifest more frequently within these regions, fueled by the intense magnetic dynamics present within sunspots. The sun's dynamic behavior, including the release of solar flares and coronal mass ejections, poses a significant threat to Earth's technological infrastructure and human activities. These solar storms, driven by complex interactions within the sun's magnetic field, have the potential to cause widespread disruptions and even pose risks to space missions and satellite operations. Solar storms, such as solar flares and coronal mass ejections, are powerful eruptions of energy and particles from the sun's surface. These phenomena can release massive amounts of electromagnetic radiation and charged particles into space. When the solar storm occurs, you won't notice it right away. It takes a few minutes before it reaches Earth. But then, the first thing you might notice is the mesmerizing auroras, painting the sky worldwide. These dazzling displays happen when charged particles from the solar storm interact with Earth's atmosphere. But don't let their beauty fool you. Solar flares wreak havoc on our technology. Satellite GPS and radio transmissions become spotty, and your cell phone might lose its signal. Now, imagine not just a single solar flare, but a full-blown solar storm, comprised of multiple attacks by the sun on Earth. And it's not just us down here feeling the effects. Astronauts in space face even greater risks. The intense solar radiation could be deadly, causing radiation sickness or even cancer. But the chaos doesn't stop there. A few days later, another threat looms: a coronal mass ejection, or CME, hurtling towards Earth. A CME is like a massive explosion of plasma and electromagnetic radiation from the sun, causing violent geomagnetic storms that interfere with Earth's magnetic field. The solar wind and magnetic fields from a CME can also compress and distort Earth's magnetosphere. We've seen this before. In 1859, the Carrington event disrupted telegraph communications, but today, the consequences would be catastrophic. This time, the tech disruptions wouldn't merely manifest as occasional glitches or patchy signals. Instead, a solar storm of unprecedented magnitude could render all technology inert. The sheer intensity of electromagnetic radiation could devastate power grids and communication networks on a global scale. Even mundane tasks, like using a credit card to purchase groceries, would become unfeasible. We're facing the prospect of a complete worldwide blackout. Imagine being on an airplane, where the cockpit loses contact with air traffic control due to the radiation onslaught, leaving the plane disoriented and vulnerable to disaster. Similarly, subways and trains could grind to a halt, leading to widespread chaos and accidents. The consequences would be catastrophic: planes plummeting from the sky, trains careening off tracks. The loss of power wouldn't be confined to households. Entire cities, including critical facilities like hospitals, would be plunged into darkness. Without electricity, medical treatments would become immensely challenging, if not impossible, leading to countless casualties. The breakdown of technology and power infrastructure could result in a staggering loss of life, with millions at risk. So, the next time you see the auroras dancing in the sky, remember the power of the sun and the potential impact of a solar storm. Thanks for watching. Don't forget to like, share, and subscribe for more informative content.